In Xendee's design software, you can model microgrid projects that vary in size and complexity. Most projects, including the projects you've seen in our Xendee University video so far, are what we call single-node projects. This means we're representing the site demand as one aggregated load, and everything is connected at the same location, or the same node. However, you may want to model multiple distributed points or loads. One of Xendee's most powerful functionalities is the ability to model in multi-node. In this video, I'll cover the differences between single-node and multi-node modeling, and when to use each for microgrid modeling. Additionally, we'll learn about power flow and what it looks like in Xendee's multi-node functionality. As previously mentioned, most microgrid projects can be represented on a single-node model, where you have one electricity load profile that represents the entire electrical demand for your site, one cooling load profile that represents the cooling demand for your entire site, and so forth. Additionally, single-node modeling assumes that the utility connection is directly connected to your aggregated building load. Single-node modeling is convenient as it allows for you to look at your site's energy profiles holistically, and is intuitive to set up. However, single-node modeling ignores spatial details. Multi-node modeling can be advantageous for bigger and more complex sites such as airports, university campuses, or sites with a big network of building loads and DERs placed at different locations. We're also introducing a new concept that is not present in single-node modeling: power flow. Multi-node modeling is useful for projects that require attention to power flow and location of assets. In multi-node, users can add multiple nodes, aka points of connection, assign multiple loads or DERs across different nodes, add cables and transformers between nodes with the ability to let Xendee auto-size for you, capture power flow and losses across the entire network, and add equipment-specific expenses for a complete bill of materials. With these capabilities, multi-node allows you to optimize DER sizing while accounting for power flow and losses throughout the network. Before we dive into how power flow works in multi-node, we need to first understand power flow analysis. Microgrids are distribution networks. In the network, there are nodes, like buildings and equipment, and branches that connect them, like cables or transformers. One node, called the slack bus, anchors the system's voltage. A power flow analysis is a simulation methodology used to determine voltages at each bus or node, power flows through each line, including real power, which does useful work, and reactive power, which maintains voltage equipment, and finally, power losses in the system. The simulation provides a steady-state snapshot or a quasi-static time series of the entire network under normal operating conditions. For distribution of a load, power flow can either be three-phase or single-phase. Residential homes in the US are usually served by a single-phase power supply, while commercial and industrial facilities usually use a three-phase supply, like residential buildings in, for example, Europe. For three-phase circuits, the system can be balanced or unbalanced. In a balanced system, the voltage and current in each of the three phases are equal in magnitude, and the phases are 120 degrees apart from each other. This enables a steady, constant delivery of power, which is what we assume to be normal operating conditions. If the above condition is violated, the circuit is said to be unbalanced. This can be caused by a fault in the electrical network or electrical equipment. Now, let's talk specifically about how Xendee's multi-node models power flow. Essentially, multi-node is a combination of technical economic analysis plus basic power flow. This is different from a full power flow simulation engine. The multi-node tool leverages optimal power flow, which is a basic version that utilizes linearized equations. The optimizations are completed using representative data types and an hourly resolution to speed up the processing time while preserving essential system behavior. The goal of the basic power flow in multi-node is to capture losses and bottlenecks in the distribution system due to the introduction of distributed energy resources. Thus, the flow of power and energy can also be considered in a techno-economic design model. Additionally, the multi-node power flow also assumes a three-phase balance system, meaning that each phase has equal voltage and current while maintaining the same phase difference from each other. A uniform delta Y configuration to step up or down voltages with transformers. Linearized distribution flow to simplify calculations by approximating voltage drops and power flows as linear functions of power injections. And the utility connection as a slack bus. Note that in an off-grid model, the islanded connection node with a generator serves as a slack bus. The linearized version allows Xendee to efficiently solve for DER sizing and dispatch for technically economic analysis while capturing real and reactive power flows. Additionally, it can minimize system losses and total costs across all nodes. However, it does not capture power flow with the same level of sophistication as in a full power simulation engine. But we have a full power flow tool as well. It's called the one-line tool in Xendee. One-line is an electrical power system simulation tool that leverages normal power flow. It's a graphical representation of an electrical power system that is designed to perform simulations in higher resolution data with smaller time steps. It supports snapshot power flow and short circuit analysis, which can give you deeper insights into system behavior. However, it is not an optimization tool and requires the users to clearly define all components. Therefore, it's ideal for detailed power system analysis once you have finalized your microgrid's DER design and know their physical placements. Lastly, you can directly import results from a multi-node optimization into the one-line tool for further analysis. As you can see, there are several tools available for your microgrid modeling needs. So how do you know which tool is right for your project? Let's start with comparing single node and multi-node. You may want to model your project in single node if you're doing a high-level screening or feasibility study for a site, you have limited details on equipment or technology placement at your site, your site is small enough that power flow losses are insignificant, or you would like to run time series or multi-year optimizations. Note that time series and multi-year optimizations are not currently supported for multi-node projects in Xendee. While single-node models can still have a high degree of detail and complexity, it's likely redundant to model in multi-node if you are in a preliminary project phase. On the other hand, you may want to model your project in multi-node if you would like to capture power flow across the entire system, account for energy losses when sizing the optimal capacity of technologies, account for cable and/or pipe lengths in power flow, or ensure voltage stability throughout the system. These guidelines should give you a good idea of whether you should start in single node or multi-node. But if you're still not sure, you can always start with single node. Then, if you want to convert your project into multi-node, it's as simple as switching a toggle in your project settings to turn your project into a multi-node project. Once you enable the multi-node toggle for your project, you'll see additional options and symbols become available in your model. In the next couple videos, we'll cover the basics of multi-node modeling in Xendee, as well as multi-node elements and power flow options. So stay tuned if you want to learn more about multi-node modeling.